This is Earth, our one and only home. Every person you have ever known, every story ever told, and every tragedy in human history has unfolded on this small, fragile world. It's where our journey to grasp how big the universe is begins. The moment we leave Earth. The first great landmark in space is the Moon. At its closest, the Moon is 363,300 kilometers away, and at its farthest, it is 405,500 kilometers away. To put that into perspective, it's about 30 times the diameter of Earth. In fact, the distance is so big that all 7 planets of the solar system could fit between Earth and the Moon if their diameters were added together. It takes light 1.3 seconds to travel from the Moon to the Earth. From the Moon, Earth appears so small, almost delicate. A blue and green marble floating in the blackness of space. Seeing it from that distance strips away all the noise, the borders, the conflicts, the divisions. What's left is just home. But the Moon is only the first step. Our next milestone is the Sun, the engine that powers life itself. The Earth is approximately 93 million miles, 150 million kilometers, away from the Sun, a distance known as 1 astronomical unit. AU. If you were driving at 60 miles per hour non-stop, it would take over 177 years to reach the Sun. That's enough time for the period from the Napoleonic era to the 21st century. Even light, which moves at an unimaginable speed of 300,000 kilometers per second, takes 8 minutes and 20 seconds to make that journey. The amazing thing about the Sun is that it reaches us with just the right intensity to keep our planet alive. If it were too close, we would be scorched. If it were too far, we would freeze to death. It is just perfect in its position. Don't you find that fascinating? Beyond the Sun, we set our sights on Mars, the mysterious red planet, humanity's next frontier. The distance between Earth and Mars varies due to their elliptical orbits. At their closest, they can be about 54.6 million kilometers, 33.9 million miles apart, though this has never been observed in recorded history. The closest documented approach was 56 million kilometers, 34.8 million miles in 2003. At their farthest, the planets can be up to 401 million kilometers, 250 million miles apart, when on opposite sides of the Sun. On average, the distance is approximately 225 million kilometers, 140 million miles. To put that in some context, the Moon is about 384,400 kilometers, 238,855 miles from Earth. So Mars, at its average distance, is roughly 585 times farther than the Moon. A commercial airplane flying at 900 kilometers an hour, 560 miles per hour, would take over 28 years to reach Mars at its closest distance. But Mars is still within reach compared to the true giants of our solar system. As we push farther outward, past the asteroid belt, past the swirling gas behemoths of Jupiter and Saturn, we finally arrive at Neptune, a lonely ice giant that marks the edge of our solar system, at an astonishing 4.5 billion kilometers from Earth. Neptune is about 30 times farther from the Sun than Earth. As a matter of fact, light from the Sun takes about 8 minutes to reach Earth, but takes 4 hours to reach Neptune. From this distance, Earth would not be visible to the naked eye. Even with advanced telescopes, Earth would appear as a small, faint dot against the background of stars. The Sun would also appear much smaller and less bright from Neptune compared to how it appears from Earth. At the very edge of our solar system, where the Sun's warmth barely reaches and darkness stretches endlessly, lies something almost mythical: the Oort cloud. This huge, invisible shell of icy objects is so far away that even calling it part of our solar system feels like a stretch. To give you an idea of just how far out we're talking, the Oort cloud is believed to extend 100,000 times the distance from Earth to the Sun. To put this distance into perspective, if you were traveling at the speed of light, it would take about 5 to 100 hours to reach the Oort cloud. It contains billions or even trillions of icy bodies, thought to be remnants from the formation of the solar system. It's also believed to be the origin of long-period comets that occasionally enter the inner solar system. But where exactly does our solar system end? There is no signpost, no grand gateway announcing the transition. Instead, scientists define the boundary by the reach of the sun's influence, specifically the heliopause. This is where the solar wind becomes too weak to repel the incoming radiation and particles from interstellar space. Beyond this point, the sun's influence fades into insignificance. This is where our solar system ends, and the true journey into the galaxy begins. And if we do step beyond, the nearest stop on the cosmic highway is Alpha Centauri, the closest star system to our own. But close is a deceptive word in space. In human terms, this journey is not like hopping from one town to another. It's like trying to swim across an ocean without ever seeing land. Alpha Centauri is 41.3 trillion kilometers away. That's 276,000 times the distance between Earth and the Sun. Even light takes 4.4 years to reach it. Now, let's put that into practical terms. Voyager 1, our most distant spacecraft, is currently speeding through space at about 17 kilometers per second. A blistering speed by earthly standards. But at that pace, reaching Alpha Centauri would take over 70,000 years. That's longer than all of recorded human history. If our ancestors had launched Voyager when the first humans started farming, it would still be nowhere near its destination today. Although Alpha Centauri seems impossibly far, it is, in reality, just a tiny baby step in the grand scheme of things. Now, let's zoom out and look at the enormous home we truly belong to, the Milky Way galaxy. Our galaxy is a breathtaking spiral of stars, planets, and cosmic dust stretching 100,000 light-years across. It's home to at least 100 billion stars, each one a potential home to planets and perhaps to life. Within this cosmic city, we humans have only touched a tiny fraction of the landscape. And somewhere in this swirling mass of celestial bodies, there exists a tiny, insignificant bubble of influence. Scientists call it the human radio bubble. It's about 100 light-years in diameter, marking the furthest reach of our radio and television signals. Beyond this invisible shell, the universe has no idea we exist. In fact, any distant civilization farther than 100 light-years away would not be aware that humans or any living thing exists on Earth. Our entire recorded history, from the first cave paintings to the rise of the internet, has never been known beyond this point. Now, let's step even further back, away from our Milky Way. Out here, the intergalactic ocean begins, an almost incomprehensible emptiness where galaxies are the only landmarks. Our Milky Way belongs to a cluster known as the Local Group, a collection of over 50 galaxies spread across 10 million light-years. To cross from one end to the other would take light itself 10 million years. And yet, the Local Group is only a speck in the grander picture. Beyond it lies the Virgo Supercluster, a titanic congregation of thousands of galaxies, stretching 110 million light-years across. It contains over 47,000 galaxies, including the Local Group. It would take light 55 million years to travel from Earth to the Virgo Supercluster. The Virgo Supercluster has a disc-like shape, with most galaxies concentrated in a plane and others forming a halo around it. As we journey beyond the Virgo Supercluster, we encounter the Laniakea Supercluster. The name Laniakea comes from the Hawaiian language meaning immense heaven, and no name could be more fitting. It stretches 520 million light-years and contains approximately 100,000 galaxies, including the Milky Way, Virgo Cluster, and Hydra Centaurus Supercluster. It has a binding mass of about 10 to the power of 17 solar masses, making it one of the most massive cosmic structures. It was identified in 2014 using data from Cosmic Flows 2, which mapped galaxy motions rather than just their distribution. Unlike smaller clusters, Laniakea is not gravitationally bound and will eventually disperse due to dark energy. Speaking of dark energy, do you know that every single galaxy, including our own Milky Way, is being pulled by an invisible force towards a mysterious point deep within the supercluster? Scientists call this place the Great Attractor. The Great Attractor is exactly what it sounds like, a very strong gravitational force that is pulling everything in Laniakea towards itself. But the terrifying thing is that we cannot even see it. The Great Attractor lies in a region of space heavily obscured by our own galaxy. It's hidden behind the thick dust and stars of the Milky Way, making it one of the greatest cosmic mysteries of our time. What we know is that it is there because of how galaxies behave around it. But what we do not know is what exactly it is. Some theories suggest it's an unusually dense region of galaxies and dark matter, while others hint at something that defies our current understanding of physics. Beyond Laniakea, we reach the very edge of what we can see, the farthest distance light has had time to travel since the beginning of time. We call this the edge of the observable universe. Now, this is where things get truly creepy. The observable universe spans about 93 billion light-years in diameter, yet the universe itself is only 13.8 billion years old. How is that possible? To find the answer to that question is to learn more about the observable universe and the three-body problem. What better way to do that than to watch our previous video on the three-body problem? Click the video icon on the right side of your screen now to watch it. Thanks for watching. Like and share this video to spread awareness. If you haven't already, subscribe and click the bell icon so you don't miss out on our future content. This is CosmicKai. See you in our next video.